Advanced functions, creating commandlets in scripts. Now in this nugget we're actually going to do some bonus review. We're going to start by looking at a very basic function in Windows PowerShell, because I think the easiest way to understand the advantages to an advanced function is to work through the evolution of functions. So after that basic function we'll look at a parameterized function, and then a pipeline or filtering function, and then we'll step up to the granddaddy, which is the advanced function. And you'll see how you can actually build your own commandlets entirely in PowerShell's scripting constructs. We'll also look at adding help to that to really make it look like a real honest-to-goodness commandlet that's almost indistinguishable from the commandlets that are written in C#. Alright, let's start by setting a goal for ourselves. I want to write a function that is going to, from one or more remote computers, retrieve the operating system's build number, the service pack major version number, the computer name, and the BIOS serial number, since on a lot of machines that's the asset tag. Now I'm going to primarily be working in the ISE here because we're doing some scripting, so let's start off with just a very basic function. Now PowerShell is really not case sensitive, so I just typically type in lowercase because I don't have to reach for the shift key that way. But do notice that I'm naming my function in the commandlet naming style, I guess you could call it. A verb, a dash, and then a singular noun. So here's a very, very simple function. I'm going to set a variable, $computer, to a computer name. Now I could choose to set this to multiple computer names by doing a comma-separated list. I could do something like Win 2008 R2. In fact, let's just do that. And then I'm going to retrieve, first of all, a WMI class that's going to have the operating system build number and service pack. So that's going to be get WMI object, Win32 operating system. Very important to spell it right. Dash computer name, and then I'm just going to pass that computer variable. Now a couple of things to notice here, because there's some best practices going on. First of all, whenever I'm inside of a script, something that I'm going to be keeping for posterity, I do not use aliases. I didn't use GWMI, I used getWMIObject. I also spell out my parameter names. All I needed here was -co or com or -comp or something like that. But again, because this is going to be here for a long time, and I might not be the only person in the world who ever has to look at this or maintain this, I want things to be clear. And so using the full commandlet name and the full parameter name helps me achieve that. To get the BIOS serial number, I'm going to do the same thing for the Win32 BIOS class. Now I've defined the function here, but I haven't called it yet, so all I'm going to do to call it is just get the function's name. It's important that function definitions appear before you try to use the function. PowerShell has to see the function and get it in its head before it can actually let you call it. So having done that, let me just run. And it did what I asked it to. It's not super fantastic. The information's spread out. I've got all the operating system information up here. It didn't actually display the service pack major version, so let's go back and change this to select just the build number, service pack major version, and I'll show you a little trick here. All WMI objects come back with an __ server property, and that contains the computer name that it came from. So down here we'll select serial number and __ server. So this time we did get the information we were at. Here's the build number, service pack major version number, and the __ server. Looks like this particular one is not displaying. Yeah, see, the problem with the serial number is it wasn't in this first set of output, and so it doesn't get picked up when the second object hits. So, alright, the bottom line is a basic function like this is not always great for getting information from multiple places and combining it into one consolidated output. And actually there's another problem with this basic function, which is that anytime I want to change the list of computer names that I'm pulling from, I have to open this in the ISE and change this. So let's fix one problem. Let's change this and make this a parameterized function. Parameter computer name equals localhost. And you know what? This is always going to be a string, so let's just make sure it's a string. And then I'm going to delete that static assignment. And since I changed my variable name to computer name, I need to stick it out here. Now what this is doing is defining an input parameter named computer name. It's a string, and it is going to default to the value localhost. If I run this without providing any other values, then that's what it's going to provide. Now, there's two ways I can actually provide a parameter. One is to give it a separated list here. If I had multiple parameters, I would separate those with a space. So this would be, say, the second parameter. So this comma separated list is the entire first parameter, and this would be the second parameter if I had one, which I don't. Not a named parameter here, because this is the first parameter in the definition, then it gets the first parameter when I run it. So if I run this, the RPC server is unavailable. Oh, did I type the computer name wrong? So you got to watch out for that sort of stuff. Yeah, I did. But that's okay. The other way you can do this is to use it as a named parameter and put dash computer name. Because this matches this value will get attached to that variable. Now, that's all well and good, but it still doesn't fix the fact that our output is getting we're not really getting the output we want. And again, that's because we've got this set of objects going into the pipeline first. And so when PowerShell decides to format things, it's formatting them based on this object. So when this object winds up in the pipeline, PowerShell wasn't ready for it, and so it doesn't include it in the formatting simply because it didn't see it there to begin with. PowerShell works best when your functions output a single consistent object. And you can see here we're not doing that. We're outputting one of these, and we're outputting something completely different, one of these. So let's start completely over. I'm going to create a new type of function called a filtering function. Now this function is unique in that it consists of three named script blocks. The first script block is named begin, the second one is named process, and the third one is named end. This function is designed to accept pipeline input. Now I'll show you one way that you might get that input in there. I might run get content from a file like computers.txt and pipe it to get inventory. Now let's hop down to the regular shell real quick. Just make sure I have a computers.txt. I do, and that's got a couple of computer names in there, one of which I'm pretty sure isn't running on my network right now. So I'm just going to edit that. Notepad computers.txt. Let's just stick localhost in here. So I'm going to get those computer names and pipe it to get inventory. Now once I pipe that to get inventory, here's what happens. Whatever's inside the begin script block will execute first. In a different scenario, I might use that to set up a database connection or something else that I plan to reuse multiple times within the function. After that runs, the process script block will run one time for every single pipeline object I input. And we saw this file has got two computer names, so that means the process script block would run twice. Finally, the end script block will run. And that's a good place to close any database connections or do any cleanup that you need to do. I typically always include the begin and end, even if they're empty. You don't have to. If you're not using them, it's okay if you leave them out. Inside the process script block, I will have access to the current pipeline input through the $_ variable. So since I'm piping in computer names, or strings really, this is going to contain the first one, and then the second time the process script block runs, it'll contain the second one. Now I'm going to grab that same get wmyObject Win32 operating system from the computer. The trick is this time it's only doing it to one computer, because this process script block is running once for each that was piped in. So I'm only working with the output from a single computer, and that's going to become important. You'll also notice that I'm saving the information in a variable rather than just allowing it to fall through to the pipeline by itself. And I should stick with the advice I just gave you and use the full computer name parameter name. So really the problem we ran into in our other function was that Windows PowerShell wants to see a single consistent object type in the pipeline. It's not really a limitation of the shell. It can work with multiple objects in the pipeline or multiple types of objects, but it works best and it's easiest when there's a single object type. So what I'm going to do is create a new object of the type PS object. That's a blank object. It doesn't have anything really associated with it. It's a blank canvas. And then I'm going to pipe it to add member. And I want to add a member to it. And the type of member I want to add is a note property. I want to name it computer name. And you'll notice that I'm being careful on the casing here. And that's just because while PowerShell doesn't care how I case computer name, it will preserve it in the output. And I want my output to look nice, so I'm going to capitalize it like this. And the value I'm going to put there is whatever's in the computer variable. And then I'm just going to repeat this. Add another member, note property. And this time I'm going to add build number. And this is going to come from the operating system build number property. And then I'm going to do the same thing again. And this time it's going to be SP version. And the actual property is service pack major version, but that's so long. I'll just shorten it to SP version. And then I'm going to add a last note property called BIOS serial. That'll be OS serial or BIOS serial number. And my last step is to write that out to the pipeline as my function's output. So here's what happens. I've got two computer names. I'm going to pipe them both to get inventory. The begin script block will run. It's empty. For the first computer name now, the process script block will run. It'll retrieve the OS and BIOS information, construct my custom object, and write it to the pipeline. And then process will execute again for the second computer. Get its OS and BIOS, construct the custom object, and then write it to the pipeline. And then the end script block will execute, and it's empty, so it won't do anything. So let's run that. And there it is. And you can see this time that I got nice formatted output. And that's because I gave PowerShell objects. And PowerShell already knows how to turn objects into a nice table with little lines and everything else to break things up. I could probably make the formatting a little bit nicer. Let's switch back over here to the script and tell it to format table, which it was going to do anyway, but let's give it the auto size parameter. Run it again. See, now I've got a little bit more room to display everything, so I get all the information I was after. And here's another advantage. Let's say you don't want it in a table. Let's say instead you wanted to export it to a CSV file. Well, you can do that. Because your function is outputting objects, you can leverage all of the different object manipulation commandlets and capabilities that PowerShell has. Maybe I don't want to export everything. Maybe what I want to do is say only keep the ones where the build number, that's an underscore, build number is equal to 7600, and the SP version is less than 1. In other words, show me all of the Windows Server 2008 R2 computers that have a service pack version less than 1. So this is a good way to check to see which computers don't have aren't on the latest service pack. So again, because my function is outputting objects, I've got all this capability. Now, I do have a couple of sort of downsides here. One is that although this looks and feels a lot like a commandlet, it can sit in the middle of the pipeline here, it cannot do parameter binding. And that means if I wanted to go get computer names from Active Directory instead of from a text file, it actually gets to be a little tricky. I'd have to go reprogram the way I did this. If I was doing get AD computer filter star to get all the computers from Active Directory, since I'm getting computer objects, I need to come in here to my function and say, well, I can't just take the whole object as the computer name. It's actually going to be the object's name property is the computer name. And that's fine. That's not a huge change to have to make, but what I'd really like to do is have this behave more like a commandlet. And that's where we really come to the point of our show here today, is called an advanced commandlet, or an advanced function, or a script commandlet. It lets you actually write a commandlet that looks and behaves like a real commandlet, only you're doing it from the scripting language, not from something like Visual Basic or C#. So here is the ultimate evolution of a function in PowerShell. Now, let me just walk through it. I've still declared the function name as getInventory, and I still have this begin, end, which I'm not using, and process script block. The process script block really didn't change from the prior version. The only difference is rather than using the variable $computer, I'm using $computer name in those three places. Everything else is the same. I'm still getting the operating system version. I'm still getting the BIOS. I'm building a blank object. I'm adding those properties to it, and I'm writing it to the pipeline. But here at top, before the begin script block, I've defined input parameters as a commandlet style input. So I have this commandlet binding. And then in a parameter block, which is right here, I defined a single parameter. Now, in addition to defining the parameter itself, $computer name, I've had to make sure I defined its data type, which is a string, and I've defined several attributes of it. Let's just back up for 1 second. I want to run help for getWMyObject. And I actually want to run the full help for getWMyObject. When you get down to the per parameter help, like the parameter as job, is it required? No. Is it a positional or named? It's named. Does it accept pipeline input? False. So let's look for one that does accept pipeline input. Actually, let's do a different commandlet because I know this one does. Where'd it go? Dash computer name parameter is not mandatory. It is a named parameter. It has a default value of localhost, and it accepts pipeline input by property name. So these attributes exist for every parameter of a real commandlet. So what I'm doing here is defining those attributes for this parameter of my script commandlet. So I'm saying it is mandatory. It does accept values from the pipeline, and this is by value, and I'll explain what that means in a second. And it accepts value from the pipeline by property name. So I've defined 3 of those attributes. So let's look at running this. The first thing I'm doing here, the first actual executable line of code, because all this is just defining my function, the first thing that'll execute is line 22. And I'm importing the Active Directory module. Now that's a module that ships with Windows Server 2008 R2. It's something that we covered in the previous nugget, number 11. And it gives me access to this getAD computer commandlet. I'm using a filter of star, which means this is going to retrieve every single computer from the domain. Not a good idea if you've got 10,000 of them, but I don't, so it's okay. And so here's what happens. I'm retrieving those computers. Those computers all have a name property. I am using the selectObject commandlet to change that name property into a computer name property. So I'm saying I want to select from this object, I want to create a new property called computer name and set it equal to whatever the object's name property is. So the output of this is going to be an object that has a computer name property. And that is getting piped to get inventory. Now when that hits up here, PowerShell has to ask itself, okay, I've got this incoming object, what do I do with it? Well, let's see, I've only got one parameter to work with here, and this tells me that the computer name parameter takes a value from the pipeline, but it takes a string. And what I've got now is not a string, it's a computer object. So this does me no good. Let's look at the next one. This says value from pipeline by property name is true. Okay, well, the parameter name is computer name. Does the object I'm looking at have a computer name property? And because of this, it does. And so that computer name property gets attached to this variable. So when the process script block runs, the computer name from Active Directory is in this computer name variable. So I'm going to comment this out here, so we're only running one thing at a time. Let me run this, clear the output, run it. Yes, I know you have to save the script. So it went, got my computer name out of Active Directory, ran the query, got my build number and my service pack version and my BIOS serial number. Sometimes I might not want to get computer names out of Active Directory. Sometimes I might want to use a list of computer names. And so here again I'm using getContent to retrieve the contents of ccomputers.txt. Now that's going to output a bunch of string objects, and those are being piped to get inventory. So again, PowerShell has to ask itself, what do I do with this? Well, I've got this value from pipeline equals true, and this parameter is a string. So did I get a string object? Well, yes, I did. So since it's a string object, this is going to allow me to attach it to this variable. So when I clear my output, run it again, both of my computer names were pulled as the input. So the practical upshot is that writing your script in this fashion really gives you ultimate flexibility. Because I can treat these parameters like real honest-to-goodness commandlet parameters, I can have them grab pipeline input both by their data type, in this case a string, or by their property name, in this case computer name. I can use this same commandlet in both situations, and I've even got a third situation I can use it in. If I don't want to pipe it anything at all, In fact, let's just comment out these lines so they don't run. I could also just say get inventory dash computer name Win 2008 R2, because this is now built like a regular commandlet. So that dash computer name is going to just attach right to it because I said it was a named parameter. So when I run this, I get exactly what I was after. So I've got 3 different ways that I can use this thing. That's ultimate flexibility. The fact that I've built it as a commandlet and I've built it to output objects is really where the power comes from. So now at the end of get inventory, I could choose to sort them on computer name. I could choose to filter them based on service pack version. I could export them to a CSV file. I could run convert to HTML and out that to a file. I can do anything I want to because I output objects. So this is sort of really where you should want to take any function. Anytime you've got something that you're going to do over and over and over, getting it into this form gives you the most flexibility both for input and for output. But we're not quite done. Let me create a new file here, and I'm just going to grab my function. I'm not going to grab all the code that actually calls the function. So we're just going to copy, close, paste, and we'll save this as getinventory.ps1. One of the things that I kind of have a problem with here is that there's no help for this function. And PowerShell actually gives us a way to do it. Let's break out of here, and it's called help about comment based help. So this is actually a special form of comment that allows you to define inline help right within a function. And it breaks down all the different keywords that you can use. Here they are: synopsis, description, parameter, and so forth. So that's what I want to add in here. So back over here in my function, at the very top of it, I'm going to create a block comment. And I'm going to start using those special keywords. So the first one is synopsis. And the keyword goes on a line by itself. This retrieves the operating system build, service pack version, and asset number from one or more remote computers. And next up, let's just put some description of the parameter. So the parameter is computer name, accepts a computer name, can be pipeline input as a string or a computer name property. And then let's chuck an example in here. In fact, the best place to get some examples is in the file I just had open, which is right here. So let's grab these 2 lines. Actually, I'll show you a little trick. I'm going to grab all these, copy, and paste them right into here. Okay, indent these because I'm a little picky about my formatting. And this is also an example. And this is also an example. And so now we'll save that. So where does that actually become useful? Well, I'll tell you. First of all, let me drop down to the shell so we can sort of look at this in a standard PowerShell environment. I need to change to the folder where that's located, users, administrator, documents, and there's get-inventory ps1. So I'm going to dot source that. Dot get inventory. Oops, need to give it a path. Get inventory. Now that didn't do anything. It just loaded that, it executed that script in the current scope, but that defined the function. If I look at my function drive, you can see that my get inventory function is now loaded into the shell. And so now, let's see that help get inventory. And you can see there's my synopsis, there's the syntax, and wait a minute, where's the examples? Well, remember, examples don't show in the standard short form help. I actually have to run help get inventory dash example. And there's my examples. Or I could have run dash full, and that'll also give me my parameter help. And look, it's breaking this down. The computer name parameter accepts a computer name. Accept pipeline input, yes. By value and by property name, it's mandatory. It's position 1. So these are all that it's really grabbing all that metadata out, and it's treating this just like a real commandlet. And of course, I really recommend, let's go back to this help about comment based help. There's lots of different look at all of them. There's lots of different bits of help you can put in here. Synopsis, description, a description of each parameter, one or more examples. You can indicate what type of input it accepts and what type of output it produces, some additional notes, links to related topics or content, all this different information and stuff you can put on there. So I really recommend you fill in as much of that as possible so that you can produce a completely self-documented function that looks and feels like a commandlet. If you give this to someone else and they're accustomed to using Windows PowerShell, then they're accustomed to being able to get help for things. And so this is going to help them do that. Now, the way I'm showing you here to distribute this is just to copy the file and then dot source it into the shell. But in the next nugget, we're going to look at modules, which is an easier way to share and distribute these things amongst a large group of people. So that's definitely something that you can kind of leverage as you start building more fully functional advanced functions. In this nugget, we've looked at the evolution of functions. We started with a very basic function and then parameterized it to make it a little bit more flexible. To give us even more flexibility in accepting pipeline input and producing good pipeline output, we switched up to a filtering function, or a pipeline function I call them. But then the ultimate in flexibility, giving you the most opportunity to accept different forms of input and produce the right form of output, is the advanced function, which some people call a script commandlet. And you can make that even better and make it look even more like a real commandlet by adding that comment-based help. So you've really got the opportunity to modularize things, even long, complex sequences of commands, into something that's self-contained, self-documented, and as flexible as you need it to be. I hope this has been informative for you.